Have you designed up your amazing project in your Vectric software and you did all the tool paths and you look at the clock that Vectric is calculating out as to how long that project should run, and your eyes bug out of your head because you can't believe that that project is going to run for 5, 10, 15 hours when you're thinking it should run for a half hour, an hour, maybe 2. Well, if you're thinking that, you're probably right. You just don't understand how to get the times adjusted properly. I'm Garrett with IDC Woodcraft, and welcome to this tutorial video where I'm going to walk you through the Vectric software and teach you exactly how to get these times adjusted correctly and to optimize your tool paths. So I'm going to run through 3 things in this video. The first and the second are super easy. The third is going to take some work on your part. You have to understand about your toolpath setups. So that's what we're going to work on. And I'm going to run you through this welcome sign project. It was actually my very first full-blown project. And because it was my very first full-blown project a long time ago, very inefficient, Vectric says it would run at 5 hours and 16 minutes. So we're going to take this project and I'm going to teach you through this project how to get the times down in your project. So we're going to get into the Vectric software and get this taken care of. Real quick before we get started, this actually turned out really cool. And so this vector is now available on my IDC Woodcraft website and on my Etsy store. So links will be down below if you want to make this cool project. All right, let's get into the Vectric software. We're in the Vectric software now, and we are going to work on this welcome sign. We're going to check the time. We're going to see that it's running way too long, and we're going to fix things to get this thing down to an appropriate, realistic time. So first of all, this welcome sign, we're going to look at it and see what all is being done to it. Number one is we have a bit of V-grooving going on in this little flower plant at the top. Second, we have 4 holes on the corners, mounting holes. Got one here, 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 and here. 3, we've got this recess cutout. We have the top surface here, top surface of the letters, and then it goes down a certain distance. So all this material here gets cut out. 4th is we have the side profile. Let's see if we can get this turned the right way. I'm going to click this little X button right there, and it rotates it. And you see we got a radius cut right over here. So that's using a ball nose bit. And then finally we have our cutout of the project, or the profile cut. So that's all the processes that are going to go on in this sign. Now this welcome sign, just so you know, is one of my first full-blown projects, and it's quite nice. It's about 23 inches wide and 18 inches tall. And if you want, you can get this vector file on Etsy or on my website. The links will be down below in the description. First thing we want to do is come over to our tool paths. And next to the word toolpath is a white box. We want to check that box. When we do that, all the boxes next to all the toolpaths down here check, and that makes them visible. And you can see all the blue lines have now shown up. There's some red lines in here. Right there, there's some green lines. I'm going to explain what these different lines are because they're relevant to solving this time problem. The blue lines are the actual cut motions of the router bit. We're going to reorient that. So you can see the router bit is going to move across this blue line here, and it's going to come up to this point, and then it's going to come back again. And it's going to go all over this project, so you can see all the tool paths here because they're all checked here. If I uncheck that, everything goes away, and then I can go and just check one. I'll check the V-carve, and there it is. It's going to be this flower thing right here, and that's it. The red line is rapid motions. That's when the bit has raised up above the project and it rapids to its next position. And then finally, you have the cyan lines, which are the plunge rates. That's where the bit is actually going down in. Now to you it looks green, and it is, because green is the rapid pull out of the tool after it's finished its cut. So there are cyan lines in here. You can see one right here. We'll show this to you so you can see them all. There's a whole bunch of cyan lines in there. Okay, so all this is relevant. So the first thing we're going to do is go into the clock to see how long this project actually runs. So we click the clock and we look at our accumulated time, and it says this sign is going to take a ridiculously long 5 hours and 16 minutes. So here is where we're going to fix problem number 1, and it's super fast, super easy, and it's going to take a ton of weight off your shoulders. You see this here that says scale factor underneath all your toolpath times, and there's the number 2 in there. Vectric is defaulted to a 2, and what it's doing is literally doubling all the times that are listed here. So it's calculating all the time it's going to take for this tools to go around, and then it multiplies it by 2. I have no idea what this is there for, at least in the hobby space of CNC routers. So the first thing you're going to do is change that to 1. And voila, we just cut our time in half. And this is far more accurate of what you're going to get now. So right now, this project, truly, regardless of the scale factor, is going to run at about 2 hours and 40 minutes.
Can you believe it? We just knocked the time down on the welcome sign in half by that one little change of the scale factor. I'm not sure why Vectric defaults to 2 on that, but go in, change it to 1, and Vectric will hold that number from now on. So if this little tip gave you a big fat, whew, thank goodness, then give me a big fat thumbs up on that thumbs up button right below this video. And a comment, say, thanks Garrett, you just saved me a buttload of time. Now we're gonna get into another little quick fix. It's not going to be real impactful, but something you should probably know about it. So let's get back into the Vectric software.
You see this number says rapid rate. What that is all the red lines are points at which the router bit has pulled up and is rapiding to its next position. So you can see there are red lines that are showing around. You can't see them very clearly. There you go. So they kind of crisscross all over the place. The rapid rate is what your machine is set at for a rapid move. So we'll take the long mill, for example. The rapid rate would be about 157 inches per minute. And so I'm going to change that back to 100 because that is the default that is usually in there. And you see we have 2 hours and 40 minutes. When I change it to 150, it's not going to change that much. So I put in 157, and it changes to 2 hours and 38 minutes. So it knocked a couple of minutes off. Basically, there's not a lot of rapid time in the project, but this is a more realistic number because that's what the machine runs at. If you have one that's running at 500 inches per minute, it starts to change a bit too. If I change this to 500, it knocks about 10 minutes off. So you get an idea. So these two things, when you set these up properly, will give you a more realistic way that this is all going to calculate out. So that takes care of problem number 1. Now we're going to close the clock and we're going to take care of problem number 2, which is just as easy. You have to be aware of something. But first I'm going to show you what to do, and then we're going to talk about what you need to be aware of. You see in the top of the machine setup, there is a button that says Set. Click that button and come down to the bottom where it says Rapid Z gaps above material. There's a little picture here, and then there's 2 text boxes here, or number boxes. And the way these 2 boxes work is the top number is what they call the Z clearance. So what that means is we're going to reorient this, is when the router bit finishes a cut and needs to pull out, it's going to pull out to the distance that you set in this first box, the clearance or Z1, which is that taller line on the little image there. Basically, every time that router bit needs to pull out, it's going to come up by 1 inch and it's going to move around. And then the second box is the plunge position. So right now that is set at 0.2. So the bit will wrap it up 1 inch. It'll move to its new position. It'll wrap it back down to 0.2 of an inch above the part, and then it'll start to go in at what we call a plunge rate. Now, a plunge rate is the speed at which the bit will enter the material in a vertical direction. Once it's reached that plunge depth, then it's going to go into its feed rate while it's cutting sideways. These numbers, you typically want them to be relatively low. Now, before I change them, we're going to go back to the clock just to see what we have. And you're going to see a remarkable change. So it's 2 hours, 38 minutes. We're going to come back, we're going to go back into the set function, and we're going to change this clearance to 0.2, and we're going to change the plunge to 0.1. So what we have done is now the bit will not pull up 1 inch, it'll only pull up 0.2 inches. It'll move over, wrap it down 0.1 inch, and then start to plunge into the part. So we've eliminated all this distance all these many times across this project. We're going to click OK, and it's going to recalculate. It's going to say the material setup values have changed, which means that the toolpaths have changed, and now it needs to recalculate. So we're going to click Yes, and it's going to go through a recalculation of all the toolpaths, and then it's going to tell us it's done. We close that, and now when you look at the image, you can see those lines. Let's go back to that orientation. And you see now those lines are all really close to the part. So we've eliminated all that travel. And we're going to click the clock again. And by doing that, well, we knocked off about 20 minutes. We're now 2 hours and 21 minutes. So we've now knocked off about 3 hours off this part by these two simple changes.
Stop for a moment and explain to you why this Z clearance adjustment is there and why we don't always want to make it so close to the part. So we're going to look at this stacked text project for just a minute. I love CNC. And by the way, if you've been wanting to do a stacked text project, I've got a Vectric tutorial for beginners that walks you step by step how to do this type of project. It's a lot of fun. They come out really, really cool. So let's say we're drilling these 4 holes, this one, the one, and the 2 on the other side. And the drill bit comes through into this hole, drills it, and it comes up, and then it moves across, it rapids across over to this hole, and then drills it. And let's say we're holding the project down with clamps, just like these soft clamps I made here. And we'll just say it's right there. So if we pull out 1 inch, there is plenty of room for the router bit to go across. It won't hit the clamp. However, if we only come up by 0.2, when that router bit comes across, it's going to hit the clamp. And if you have hard clamps, it's not the clamp that's going to give. It's the router bit that's going to break, and you don't want to break a $40 router bit. So when you know that you're going to have clamps in the way, then you absolutely want to make sure your Z clearance height is going to take into account the thickness of your clamp. But this is exactly why I make my own clamps out of soft pine, because when the router bit runs into it, it literally just runs right through it, and it ruins the clamp, but it didn't ruin my router bit. And I have a whole bunch of clamps because I designed this file to have 18 to 24 clamps. That is actually available for you on Etsy. It's got the G code and everything, or on my website. So I just totally recommend you make your own, because you buy 4 clamps, they cost 50 to 100 bucks. For a sheet of 12 by 12 plywood or pine, you'll get 16, 18 clamps off of it, and You ruin it, you'll ruin the clamp, you won't ruin your bit, and you got more in the stockpile. So, of course, down in the description is a link for that if you want to get that. So now we are going to get into the most important and the most timely part of this video, where it really is going to make the big world of difference on this project of whatever you're running now that you're trying to solve and all your future projects. It has to do with your tool library setup, the settings for all your router bits. They are inappropriately set for your machine, probably. It really depends. For example, with this welcome sign, when I designed it, I had a Bob CNC router, and it was just not a robust machine. I wanted a much more robust and aggressive machine, and after my research, that's why I came to the long mill and why I recommend it. We're going to work on the library settings for the router bits in this project and get it tuned up the right way. This project should be running under an hour. So we're down to 2 hours and 20 minutes. We're going to knock another hour and 20 minutes off the project. So let's get back into the Vectric software, sit back, relax, give me a thumbs up and a comment, and subscribe to the channel if you really want to learn how to use the Vectric software, because I got all these deep dive videos like this where you really get the understanding of what's going on. Okay, let's get into the software.
And we're just going to go methodically through all these tool paths to take a look to see how the router bits are actually set up for their feeds and plunges, their plunge depth. So I'm going to come in here and click next to the first one. It says vcarve 1. And I'm going to click that, and we see the tool path now, and that is doing this plant on top. And we're going to go into the clock briefly. And you see only vcarve 1 is showing up because that's the one we have checked. And it runs for 3 hours 3 minutes 46 seconds. I'm not even going to worry about that one. So we're going to come down to the tool path here. You can either check the software, the checkbox down here, or you can close the clock and then come over, uncheck the vcarve, and then check the next one, and that is the drilling operation. It's 4 holes. It's going to be lightning quick, but we're going to take a look at it. Oop, hit the wrong button. Clock. And that's going to take 1 minute 29 seconds. Now, this is done with a 1/4 inch upcutting end mill. And I'm just going to tell you now, if you're going to drill holes, it's best to use a drill bit that's made for CNC routers, because peck drilling with end mills, people sometimes get in a bad habit of using a down cutting bit to drill, and that causes fires. Upcut end mills can drill, but I strongly recommend you use drill bits. If you want to see what I mean, I've got a couple of videos that talk about drill bits. There'll be links down in the description. But we'll move on because that's insignificant too. Between these two, it's 5-minute runtime. Now we're going to go to the third one, which is the radius, that little accent that is done with a 1/2 inch ball nose end mill. That's something else that's in stock on the IDC Woodcraft store, but it adds the accent all the way around. And you can see it's making 1, 2, 3 passes. We're going to turn this on the side, and we're going to look at the blue lines, and it's not showing up quite well. You can see right there, there's 3 separate blue lines, which means that bit is going around 3 times on this part to do that finished job. So we could probably cut that down to 2 because it's not that deep. So we're going to double click into this. Now it is coming down to 0.23 inches, and it's making 3 passes around. Let's take a look at the setup on this project. I'm going to hit edit, and the bit is going at 40 inches per minute. Now, this is conservative. This is the way I set it up a long time ago. So we're going to change that to 65 inches per minute. Now, you know what? Before I do that, let's see what the time was. I keep forgetting to check the clock on that. We're going to look at the clock, and that takes 5 minutes. Okay, close. So we're going to go into the toolpath, and we're going to edit. And first of all, It's a 0.1 deep. Now with a ball nose end mill, you don't want to go to the depth of the ball.
I wanted to take just a moment to explain to you what I just said about you don't want to go to the full depth of your ball nose. So we're going to use this large ball nose as an example. This is the 1-inch ball nose off the IDC Woodcraft website. I use this for bowls and huge juice grooves if you want, or other really cool accent work on your projects. This is kind of nice to get a wavy feature in your projects. Let's just pretend that this is a 1/2-inch ball nose, which is also on the website. IDC, there's 1-inch, 3/4 inch, 1/2-inch, 1/4 inch, and 1/8-inch ball nose. So we're just going to say this is the cut that it makes, and this depth here is the full radius. So we're just going to pretend that the ball nose, that's the ball, right? This one actually goes up like that, which is the sides right there. Let's clean that back up for just a moment. There we go. And we're just going to do it like that. That's the cut of the ball nose. If you set your ball nose bit to the end of the radius, which would be right here. This is a 1-inch, so it would be a 1/2-inch deep. If it's a 1/4 inch or 1/4 inch ball nose, then it'd be an 1/8 inch deep. You don't want your first cut to be that full depth. Remember, we're talking about a big one here, even on the little ones, because what will happen on the full depth on the first pass, because what will happen is you'll get a lot of chipping going on along this edge. So in order to avoid that, you want to make it about 20% less when you're using an 1/8 inch or a 1/4 inch or a 1/2 inch ball nose. So that would be for a 1/4 inch, which has an 1/8 inch radius, which is 0.125. You want the first depth of cut to be 0.1. For a 1/4 inch, 1/2 inch, which is going to have a 0.25 radius, you want your first cut to be 0.2. And these are good numbers to be using. When you're getting up to larger ones like this, then you're going to be maybe 0.25 for the first cut, and then another 0.2. You don't want that last cut, or you want that last cut to be just below the radius, and then it's going to make its next deeper cut. What that'll do is that'll keep a super smooth, clean cut line right along here that isn't ragged, jagged. You don't have to sand. So your pass before you go to the full radius, you want to be about 20% of the depth of the radius before you get down to that full radius, and you'll get a nice clean cut. I hope that made sense to you. All right, let's get back to this project and the timing issues that we're teaching you how to solve.
So this is a 1/2 inch. The depth will be a 1/4 inch for the full radius, but you can go a little bit less than that. We're going to change that to 0.2. So it's not 0.25. We want to be underneath that. And we can change our feed rate because that's at 40 inches per minute. We're using a long mill, and so we're going to bring that to 65 inches per minute. Also, our plunge rate is 10. That's okay. We'll leave it there. We're going to select that as okay. We're going to recalculate this toolpath, and then we're going to take a look at our new time. And we are now at 2 minutes 10 seconds. We basically cut that time in half. So that's not that significant again. But it's when we start getting to the really bulky work, right, where a lot of real estate is going to be removed from the project, and that would be in this area right here. So now we're going to go on to the next one. Let's check the next one. And okay, so the next one is inside the letters. We're going to double click that, and that is going to 0.25 deep. First thing is do we need to really go a 1/4 inch deep on this project? You notice that these letters are a little thin, so the deeper we go, the weaker these points get. So the first thing I would probably do is shallow this up just a little bit and change it to 0.125 because it'll still make the letters pop. And that will basically cut the time in half. And then we're going to take a look at our tool paths. So we have 2 passes with the 1/4 inch end mill. Oh, I just want to point this out. There's 2 router bits here. There's the 1/4 inch and the 1/2 inch. We're using the 1/4 inch to do the roughing out of the inside of these letters. And then the 1/8 inch will come in and do any finish work that the 1/4 inch couldn't get to. So we're going 1/8 of an inch deep, and the 1/4 inch is taking two passes. We don't need to do that. We're going to do that with 1 pass because it's only 1/8 of an inch deep. So we're going to go in and take a look. And so we're going to change our pass depth to 0.125. These data figures are wrong in this whole file because it's such an old file. Your standard step over would be 40%. We're going to change our feed rate to 65. And we're going to leave our plunge rate at 10. And I'm going to calculate. So now you can see with the 1/4 inch highlighted, we only have 1 pass. We can do this the same with the 1/8 inch end mill. We click that, it says 2 passes. It's so shallow, there's going to be very little material left for the 1/8 inch end mill to take out. So that doesn't really matter. So we're going to change that to 0.125. And our feed rate is 0.25. We're going to change that to 40 and click OK. And now we're going to calculate this out. And now we go back to the clock. We have both tool paths selected. 2 minutes. And I don't think I checked the time on this before. But we can figure we cut it at least in half, and even more so because we increased our feed rates. We cut our number of passes down to 1. So we'll check the next one. So I do know for a fact that the next one, which is this one, is the big time taker.
Now we're going to get into the part of the project that's really taking all the time up. All the real estate between this outer boundary and the welcome. This is where most of our time is being taken up. And usually that's where you want to start off to optimize your tool path. But we're walking through the whole thing because we want to optimize the whole thing because it's an old file. So this is where you're going to learn how much of a difference doing this kind of work will improve your cut time. You'll be blown away how much time we cut down by what I'm about to show you. Now before I get into it, if you haven't already, will you please take a moment to give me a thumbs up and of course a comment. Those always help this channel rank, and you know, if you're feeling like you're getting some help out of this, then other people are going to get the same kind of help. So I would appreciate that. And subscribe if you're brand new to CNC routers, because I will teach you everything you need to know about the Vectric design software, router bits, the CNC router, and how to work all this stuff, put it together, make sense out of it. So, all right, let's dive into Vectric and really chop this time down. Let's go.
First of all, let's take a look and see where we're at right now. We're going to click Tool Paths, click the clock, and we are now down to 2 hours and 11 minutes. So we started at 5 hours and 15 minutes, and we've now cut out over 3 hours. So we're going to close that. We're going to uncheck all the tool paths, and we're going to go into the next tool path, which is taking out all that real estate. So we're going to double click it, and again we have 2 tool paths. So let's see what the time is. I'm going to close that. And we're going to find the second tool path, because Vectric will create 2 tool paths, one for every bit that is in a tool path. So that's the one and that's the other. We're going to look at the clock. This is our big time taker, 1 hour and 49 minutes. Basically, rule of thumb is work from the biggest real estate problem and work to the smaller ones, because that's the one that's going to take all your time. So we're going to double click into that. We're going to change this value to 0.125. And just with that one change, I'm going to close that. Look at the time. From 1 hour, 46 minutes down to 20 minutes by that, for 1 hour and 20 minutes. By that one little change. But we're going to bring it down even more. So we're going to go back into this. This is what it takes to really look at your project runtime. This becomes super relevant when you are starting to run production or you have larger jobs like this. This sign is 23 inches wide by 18 inches tall. So we are back in the toolpath again, and we're going to take a look at the router bits. Again, we have 2 passes for the 1/4 inch and 2 passes for the 1/8 inch. We're going to change them to 1. I'm simply going to hit the edit button, fix this number to 0.125. My feed rate is a little different here than it was in the other one. The other one was 40. I'm going to change that to 65. Our stepover is 40%. Now 40% is traditional. What I would do personally is I would up that to 60%. That's for the 1/4 inch. And the other thing I would do is a little tip for you. You see how all these lines swirl all around? The grain of the project is going left to right. When a router bit comes up and down like that, it's going across the grain and it's going to leave something called witness marks. So you want those witness marks taken out of it. And the way to avoid that is by changing your toolpath to a raster mode, which is right here. You see this little box right here, how the line swirls around. That means it's starting from the middle of somewhere in the project and it's going to swirl around following contours. When we change to raster, it's going to go back and forth. So we are going to simply go with that. And one other thing I want you to take into account is the bit is now going to go back and forth like you see in this little image, but it's also going to leave little ripples along every edge around here. And something else to take into account in this type of project where the letters are thin. We don't want to break these letters, so we are going to be a little more ginger with it. The 1/4 inch is going to rough out this project. The 1/8 inch comes in behind it to do the final cleanup. But we need to get rid of those ripples. And the way we're going to do that is by going to this profile pass. And there's a little drop down. Right now it says no profile pass. What that means is the router bit will make these moves back and forth, but it won't clean up the ripples that it's going to leave around the edges. So this will allow us to do that. And what we're going to do is we're going to do this last. So what that means, you see a first and last. What that means is first it's going to make its side-to-side cuts and then its last cut will be coming around. But we also want to leave a little bit of material left over because the 1/8 inch bit is coming in behind it. So you're getting a few extra tips here on how to set a project up right so that it works out. So in order to leave a little extra material, we want to change this pocket allowance number right here. And what we're going to do is just change that to a 0.03. And what that's going to do is leave 0.03 material around every edge that this router bit is going to be cutting. That's for the 1/4 inch. So that one's set. So now we're going to go to the 1/8 inch. And the 1/8 inch is 2 passes as well, but we don't want that. We're going to change that to 1 pass. So we're going to change that to 0.125. There's not much material for it to remove, so it's not going to work the bit too hard. You can use an up bit, down bit for this. You're okay either way with this. So you notice that now we don't not have a selection here for offset and raster because the 1/8 inch has to follow the profile. Its job is to clean up everything the 1/4 inch didn't get. So we're going to calculate, and now you notice that everything's a little bit different here. We have these nice clean back and forth cuts, and then we're just profiling around all the letters and the outer perimeter. This was a long explanation, but I hope that it made some sense to you. And we're going to close this, and now we're going to look at our clock. And for that one, we just went from 1 hour and 20 minutes to 44 minutes. And I think we're pretty much optimized here.
Now, do you see what I'm talking about? When you're dealing with a lot of real estate that you're going to cut out, how much time you can save? We knocked off 36 minutes off that cut time just by dealing with this one toolpath. So we've got 2 more to go, and I suggest that you keep on watching because I do a couple other techniques here to just tweak it down a little bit further, and watch what our time is by the time we're done with this whole project. Let's get back to it.
So the next one is this is the ball nose profile. We'll see what the time is on that first. It's 5 minutes. That probably should be a lot less. The ball nose is going to go around and do this little accent with a 1/2 inch ball nose. This is the bit that you use often on doing juice grooves. A ball nose 1/2 inch or a ball nose 3/4, and you can find both of those on the IDC Woodcraft store. I'll leave links for you down below. We're going to double click into this toolpath. It's going down to 1/4 of an inch, which I like that. We're going to stay with that. It's making 2 passes, and I think I'm just going to leave it at that. But let's take a look at our feeds and speeds here. So we're going to go to Edit, and we're running at 25 inches per minute, which is stupidly, ridiculously slow. We're going to go up to 65 inches per minute. Our step over, 10%. When you're using a ball nose, you don't want a large step over, so that's about right. And our plunge rate is 20. So we can pretty much stay with this. Now, this says 2 passes. Why do we have that? When I go in there, our pass depth is 25. This should be 1 pass. So here's where another little interesting thing comes in. You can actually edit the passes to create a finish pass. So when we click that, and you notice in here we have this little box checked where it says set last pass thickness. So what we're doing is we're making a rough out pass at almost the full distance, and then it's making a 1 final pass to do a smooth final cut. So that's what that is doing right there. So you can change that as you need. So we'll cancel that because that's already set up, and we're going to just click calculate. We know that that number hasn't changed. Well, the number did change a little bit because we changed the feed rate, and now it's 2 minutes as opposed to 5 minutes. So let's look at the cutout toolpath now. Take a look at the time, and we are going to uncheck everything. I'm going to close that for a minute. Just simply check that, and then we're going to look at the clock. And our cutout time is 7 minutes 47 seconds. So we're going to close that, and we're going to go into the toolpath because we can probably knock this down to 5 minutes. It's really 6 to 1/2 dozen the other. In this case, we've knocked out a huge chunk of our time. And we're going to take a look at our settings. So we're starting at 1/4 inch in the depth. That's because we've already got a 1/4 inch cut away with the ball nose. And so all that's remaining is 1/2 of an inch. Our material is 3/4 of an inch thick. So now you see we have 5 passes that we're going to be making. So let's take a look at our bit. One of the things is if you have a benchtop router like the long mill, it is very sturdy, can handle this, and so we are probably going to have to change our feeds again. Yes, it's 45. We're going to bring this up to 80. Then we'll bring it up to 65. I'm going to be conservative for you. Normally, I would bring this up to 80, but it's still going to make a little bit of a difference. And then we are at that 0.1 depth. Of course, we can change that to 0.25. Standard rule of thumb, this is going to be done with an up bit. So the standard rule of thumb would be the diameter of the bit as far as depth. Now, I won't do this with an up bit. I'll do it with a down bit. So that the standard rule of thumb is 1/2 the diameter. So it would be normally 1/4 of an 1/8 of an inch. So that would be 0.125. However, we are going to go deeper. I'm simply going to leave it at 0.125 for the moment. I'm going to click OK. And then we're going to come into this button, Edit Passes, because we have 5 passes. We're going to flip this around for just a moment. And we're going to look at this. And you can see there's 5 blue lines that go around the project. That means the router bit is going around 5 times. We don't want that. We have a long mill CNC router. This type of benchtop CNC router can handle cutting all the way through the project in one shot. However, because we're going to be a little conservative, assuming that you're still just learning this stuff, we're not going to do it that aggressively. So we're going to come into Edit Passes, and we're simply going to come down and change that bottom number to 2. We'll take 2 passes, a 1/4 inch per pass. And we click out of that, and we click OK. And it didn't take, so we're going to go back in to that and see what's going on. So I'm just going to come in and hit these buttons. Okay, so that changed it. So if you change the number in the box, it doesn't change, but if you use the buttons next to it, it'll change. So we're good. I'm going to click OK, and with that, we're simply going to calculate this profile cut. And we're going to close that, and we're going to look at the clock. And we've gone from 7 minutes to 2 minutes 30 seconds. So let's check out our overall time now. This is the moment of reckoning. If this video has been helpful, please give me a thumbs up, and please leave a comment if there's anything I missed, and also subscribe to the channel if you want to learn this stuff. I got a ton of videos that are teaching you just like this. All right, let's look at the clock. We have now taken a project that started out at 5 hours and 16 minutes and turned it into a 58-minute project. The welcome sign.